So hello everyone, welcome back to today's program Python Programming Fundamental series. In the previous lecture, we learned one of the most important topics in programming, which is loop. Before we begin today's lesson, let's spend a few minutes revising what we learned because programming is all about connecting concepts. If your fundamentals are strong, learning advanced topics becomes much easier. So let's quickly revise. So the first loop we learned was for loop. For a for loop is used when we already know how many times we want to repeat a task. For an example, suppose I ask you to print numbers from 1 to 10. Since we already know there are 10 numbers for a for loop, it's the best choice. So we already saw about for loop example, which is for I in range 1, comma 11, colon print I. Here, Python automatically changes value of I from 1 to 10, one by one. We don't need to update it ourselves. The second one we learned is while loop. Unlike the for loop, while loop is used when we don't know in advance how many times something should repeat. Instead, the loop continues as long as a condition remains true. Examples like count equal to 1, while count is less than or equal to 5, print count, and then we are updating count in 1. Here, the loop keeps running until the count less than or equal to 5 becomes false. Remember, in a while loop, we must update the variable ourselves. Otherwise, the loop may never stop. The third one we discussed was range function. It is mainly used for loops. We discussed three common forms like range start, comma stop, range stop, step. Using these, we can easily generate or decrease sequence of numbers. The fourth one we discussed was break statement. There, we learned that think of it like an emergency stop button. Whenever Python executes it, the loop stops immediately. So the example like for I in range 1, comma 11, colon, if I equal to 6, then we'll be breaking from the loop. Otherwise, we will print I. So the moment Python reaches 6, the loop ends completely. So after that, we learn continue. Unlike break, it does not stop the loop. It simply skips the current iteration and continues with the next one. For an example, for I in range 1, comma 6, if I equal to 3, continue, print I. So the output will be 1, 2, 4, 5. Only one iteration is skipped. The loop keeps running. The next one we have discussed was pause statement, where we learned pause. This is one of the most simplest statements. It literally means do nothing. It mainly used as a placeholder when we haven't have the actual code yet. For an example, if true, pause, print done. The program runs successfully even though the block is empty. Also, we revised match case. Instead of writing multiple elif conditions, we can use match case. When comparing one variable against many fixed variables, values, it makes programs easier and cleaner to read. Finally, we briefly introduce the idea of nested loops. A nested loop simply means a loop inside another loop. We mentioned that nested loops are useful for pattern printing, matrix operations, tables, grid-based applications, but we intentionally did not study them in detail because today's lecture is dedicated to this topic. Today, we will understand how nested loops actually work, how programmers think while solving patterns, and how to write star and number patterns with confidence. So, if you are comfortable with for loop and while loops, you are ready for this next step. Let's begin with a very interesting question. Why do programmers spend so much time learning pattern printing? So these are the things which we will be studying in this today's lecture. These are understanding nested loops, number pattern programs, star pattern programs, and then introduction to functions. There we'll be discussing built-in functions, user-defined functions, and then parameters and arguments, return statement, and some basic function practice programs. Don't they This will be like the function topics will be introductory one, and the advanced explanatory one will be in the next lecture. There we'll be discussing in the further way manner. Okay, so now we start writing now before we start writing patterns, let me ask you one simple question. Have you ever wondered why do almost every programmers, I mean every programming codes or every coding teacher or even coding interviews include pattern printing question? At the first glance, they look very simple, but you are just printing stars or numbers. Many beginners think, what's the use of printing triangles and squares? That's actually a good question, because in the real software, you rarely build an application that prints stars on the screen. So why do we spend time learning it? The answer is pattern programming is not about stars. It's about training your brain to think like a program. The stars are only a tool. The real goal is to improve your logical thinking. Let's understand how. So, first point is pattern printing improves logical thinking. This is the biggest reason. Programming is nothing but solving problems logically. Suppose I show you this pattern. Like, let me show one pattern, this one. Instead of immediately writing code, a programmer starts asking questions. How many rows are there? What changes every time? What stays the same? Is there a relationship between the row number and the number of stars? Notice something. Before even writing a single line of code, a programmer is already thinking logically. This habit is developed through pattern programming. The more pattern you solve, the stronger your logical thinking becomes. So, pattern programming helps you understand nested loops. So, the PPT also says like it can help us understand nested loops. Today, we are going to learn nested loops in detail. And honestly, patterns are the best ways to understand them. Think about drawing a notebook. There are many rows, and inside every row, there are many columns. To visit every position, you need one loop for the rows and another loop for the columns. And that's exactly what a nested loop does. If you understand pattern programming, nested loops become much easier. Pattern programming improves problem solving skills. Imagine someone asks you to print this. This is something to memorize forever. You have to observe, find the rule, and convert that into the code. Every new pattern is like solving a small puzzle. The more puzzles you solve, the better your problem solving skills become. And that's one of the most valuable skills for any programmer. The fourth one is pattern programming builds confidence. Think back to when you started Python. Even writing a simple loop probably felt confusing. But after practicing, the loops become much easier. The same thing happens to patterns. At first, you may feel it looks difficult, but after solving 5, 10, or 20 patterns, you will notice something amazing. You will start recognizing patterns automatically. Your confidence will grow, and writing code will become much more natural. So that's why beginners are encouraged to practice pattern programming. And point number 5, pattern programming helps in coding interviews. Many companies, especially during internships or campus placements, ask simple pattern-based questions in coding rounds. Not because they want stars on the screen, but because they want to see how you think, how you break problem into steps, and whether you understand loops and conditions. Even if the exact pattern is in asked, the logical thinking you develop here will help you solve many other programming problems. So, whenever we solve a pattern, don't try to memorize the code. Instead, ask yourself these 4 questions. How many rows are there? And what is printed in each row? What changes from one row to the next, which loops should control rows and which should control the columns. If you answer these four questions, most beginner patterns will become much easier. So before we move on, let's do a quick thinking exercise. Look at this pattern and don't think about a Python code. I mean, don't think about Python code yet. Just observe it carefully. Ask yourself how many rows, how many stars are printed in the first row, how many are printed in the second, how many are in the third. If you can answer those questions, you're already thinking like a programmer. The code becomes much easier after that. Let's summarize what pattern programming is. So pattern programming helps us improve logical thinking, understand nested loops, develop problem solving skills, build confidence while writing programs, prepare for coding interviews. But remember, the goal is to learn how to analyze a problem and convert into a code. Now that we understood why pattern programming is important, the next question is, what exactly is nested loop and how does it work? Let's learn in the next section. Now that we understand why pattern programming is important, it's time to learn the concept that makes pattern programming possible. The concept is called nested loops. Don't worry if the name sounds complicated. Once you understand the idea, you will realize actually it's simple. So what is nested loop? A nested loop simply means a loop inside another loop. That's it. Fine. One loop is returned inside another loop. An outside loop is called outer loop and the loop written inside is called inner loop. Think of it like a box. You have one big box inside it and there is one another small box. Similarly, one loop contains another loop. So imagine you walk into a classroom. A classroom has 5 rows and 6 students in each row. Suppose your teacher asks you to go and greet every student. How will you do it? Will you greet all students randomly? No. You will probably start with row 1. Inside row 1, you will greet student 1, student 2, student 3 till student 6. And after greeting every student in student 1, I mean row 1, you move to student 2 and again you will greet all the 6 students. Then notice something, after for every single row, you visit all the students. So this is exactly how a nested loops works. So now let's understand their responsibilities. Outer loop controls how many rows do we have and inner loop controls how many elements are printed inside each row. Think of it like a notebook. Outer loop says create a new line and inner loop says print everything on that line. This one idea can help you solve almost every beginner patterns. Let's write our first nested loop program where like for row in range 3, for column in range 4, print star comma n equal to space, and the next statement will be print with no values inside it. This makes you to have a new line, and then if I run it, I will be printing. Don't worry what is happening here, but pause the video and ask yourself how many times the outer loop runs and how many times the inner loop runs. Think for a second. Yes, and let's now execute it. See, the output is there are 3 rows where all the 3 rows has 4 columns with the star printed on it. How did Python produce this output? Let's try run it. Initially, row value becomes 0. Now the Python enters the inner loop. The inner loop runs 4 times. So it prints star for 4 times. After finishing the inner loop, Python executes print. That moves the cursor to the next line. Now the outer loop contains row equal to 1 and the inner loop starts from the beginning. It prints 4 stars and next another new line. Finally, row becomes true. I mean 2. Inner loop runs again. Then at last the output becomes as we saw in the screen. Notice something very important. For every one iteration of outer loop, inner loop runs completely. This is the golden rule of nested loops. One outer loop is equal to inner completion of inner loop. Then the outer loop moves to the next iteration and the next inner loop starts all over again. Let's try another example. For I in range 2, for j in range 3, print I comma j comma j. And if I save it and run it, what does it happen? It prints 0 0 0 1 0 2 and then 1 0 1 1 and 1 2. Let's understand why. For the first time I is equal to 0 and then j runs 0 and 1 and then 2. After that I becomes 1 and j runs 0 1 and 2. So only after finishing all the three values, the outer loop changes to I equal to 1. Again, the inner loop starts from j equal to 0. This is one of the most important ideas in nested loops. In the inner loop always starts fresh for every iteration of the outer loop. Where are nested loops used? Let's understand them one by one. So these are used in pattern printing, like printing stars, numbers, triangles, squares, pyramids, and diamonds. All these require nested loops. This is one of the first applications we are going to study today. The second one are matrix operations. A matrix has rows and columns. To visit every element, one loop has to handle the rows, another loop has to handle the columns. And then multiplication table. Suppose you want to print tables from 2 to 10 and each loop changes the table number. Another loop prints that multiplies. Again the nested loops. Games. Many games uses grids. For an example, chess, tic-tac-toe, Sudoku, Minesweeper. These games contain rows and columns. The nested loops help programmers process every cell in the grid. And fifth one is grid-based applications. Even image processing works with pixels arranged in rows and columns. Programs often use nested loops to visit every pixel one by one. So although we are starting with star patterns, the nested loops are used in many real-world applications. So let's discuss a few mistakes beginners make. Mistake number 1. Thinking inner loop continues from its previous value. It doesn't. It starts from the beginning every time. Mistake number 2. Confusing the purpose of for the two loops. Remember, one loop is the inner loop is for columns or elements inside every row. Mistake number 3. Incorrect indentation. Python depends on indentation. If the inner loop is improperly indented, the program won't work as expected. So always pay attention to spacing. So let's test your understanding. Without writing any code, answer this question. If the outer loop runs 4 times and the inner loop runs 5 times, how many times will the inner loop execute? Think carefully, okay? So the answer will be 25, which is for each one outer loop, 5 times the inner loop runs. So 4 into 5 is 20. This simple multiplication idea is very useful when understanding nested loops. Let's summarize the concepts which we studied in this topic. Like a nested loop is a loop inside another loop. A outer loop controls the loop and the inner loop controls the columns or elements. For every iteration of outer loop, the inner loop executes completely. Nested loops are used in pattern printing, matrices, tables, and many other applications. Now that now that you understood how nested loops work, the next step is to learn how programmers think before writing any program. I mean patterns. Instead of memorizing code, we will learn simple step-by-step method that works for almost every beginner patterns. Let's move to the next section, steps to solve any pattern. Now we know what loops are, but here is a question. Whenever you see a new pattern, how do you actually start writing a program? Most beginners make one common mistake. They immediately open their editor and start typing code. After 1 or 3 minutes, they get confused and they think pattern programming is difficult. Actually, the problem isn't pattern programming. The problem is starting at the wrong place. Professional programmers do not start with the code. They understand the pattern. They write the algorithm. Only after they do the they do write the Python code. Today, I am going to show you a simple method that works all for almost every beginner patterns. If you follow these steps every time, you won't need to memorize dozens of different programs. Let's learn how to build them yourself. The first step is the simplest, but also the most important. Don't write any code, just look at the pattern. Spend a few minutes observing it. Ask yourself, what actually I am seeing, how many beginners skip this step, and this is why they get stuck later. Remember, observation comes before programming. Step 2. Count the number of rows. The next question is how many rows are there? In our example, there are 5 rows. So this immediately tells us something. If there are 4 rows, there are 5 loops, our outer loop should run 5 times. And see how useful the outer loop is. This controls the rows. And that's exactly why we learned in the previous section. So step 3. Now look again. The row 1 is star, the row 2 is 2 stars, the row 3 is 3 stars, and the row 4 is 4 stars. Notice what changes? The number of stars. Every new row gets one extra star. Whenever something changes row by row, you usually become the job of the inner loop. This observation helps us decide how many times a inner loop should run. Step 4. Identify what remains constant, what never changes. In this example, the symbol being printed is always star. So this is only the quantity changes, the character itself remaining constant. Sometimes opposite happens. The number of symbols is actually the same, but the value changes. Learning to separate what changes and what remaining constant is one of the most important of our programming skills. Step 5. Write the algorithm. Before Python, write the logic in simple English. For an example, our algorithm could be repeat for every row, print the required number of stars, and move to the next line. Notice there is still no Python code. We are simply explaining the solution. Professional programmers often do this before coding large programs. Step 6. Try run the logic. Before executing the program, run it in your mind. Suppose there are 4 rows. Imagine the output is outer loop is starting. First row, how many stars? 1. The second row, how many stars? 2. The third row, 3. The fourth row, 4. If you dry run the matches and the expected pattern, your logic is probably correct. This habit saves lot of debugging time. Now, only now do we and start writing code because we have already answered all of the important steps. Okay, so Now coding becomes much easier. Instead of guessing, we already know how many rows, what changes, what remains constant, which loop controls the rows, which loop controls the stars. The code almost writes itself. Step 8. Test the output. Finally, run the program, compare the output with the required pattern. If something is wrong, don't panic. Go back to the previous steps. Most mistakes happen because of misunderstanding the pattern, not because of Python is difficult. Debugging is the normal part of programming. Even experienced programs test and improve their code. So here is a simple formula I want you to remember. Whenever you see a new pattern, ask these few questions. How many rows are there? What should be printed in each row? What changes from row to row? What stays the same? Which loops controls the rows and which controls the printing? If you answer these 5 questions, you can solve the most beginner level pattern programs without memorizing them. So let's do a quick revision. Let me go to one thing. Yep. So notice this pattern. Don't write any code. Just answer these questions. How many rows are there? What changes in each row? What remains constant? Which loop controls the rows? And which loop prints the numbers? If you can answer this, you are already halfway writing the program. So let's have a quick recap of our pattern solving strategy. First, observe the pattern carefully, count number of rows, identify what changes, identify what remains constant, write the algorithm, dry run the logic and write the Python code. After that, test the output. Don't memorize the pattern programs. Instead, memorize the thinking process. It will help you solve not just today's patterns, but new patterns in the future. Now that we know how to approach a pattern, now it's time to write our first star printing using nested loops. So let's begin with the star pattern 1. Now comes the exciting part of today's lecture. Until now we have learned the theory. We know why pattern programming is important, what nested loops are, and the steps to solve any pattern. Now it's time to put everything into patterns. We will start with some smaller, similar, simple patterns. Remember, our goal is not to memorize the programs. Our goal is just to understand the logic behind them. If you understand the logic, you will be able to solve many new patterns as they are on their own. So, pattern 1. Let's print this pattern. So, let's begin with the easiest one. So, take a few minutes, few seconds and observe it. Don't think about Python code yet, just answer few questions. How many rows are there? There are 4 rows, the 5 rows. How many columns are there? So we know output runs for the 5 times. How many stars are printed in each row? So each row prints 5 stars and the number of stars never change. That means the inner loop will also run 5 times every time. So now let's convert this thinking into code. Okay, so let's have for row in range 5 and then for column in range 5 print star comma end equal to space. After that print bracket. So if I save it and run, it prints rows with 5 times. So the first outer loop creates 5 rows. Now for each row, the inner loop starts and prints 4 5 stars. Notice we use end equal to space instead of default new line. Why? Because we want 5 stars to appear on the same line. After the inner loop finishes, we execute print. This moves the cursor to the next line. Without this statement, all 16 stars would appear on a single line. Let's execute it. So exactly what we wanted is printed right now. So now let's try to dry run once. So for row 1, the inner loop prints 5 times stars and it goes to the new line using print. Now row becomes 2. Again, inner loop prints 5 stars. Now it goes to the next row. Similarly, it happens till row 5. And after this, the loop ends and we have already printed the desired one. Notice something, the outer loop decides which row we are printing. The inner loop decides how many stars appear on each row. This is the same idea we learned in the previous section. So let's do one small experiment. What if we change this rows, the range into 6 instead of 5? And if we save it and run, changes the number of rows and columns. And what if we keep the inner loop columns as 5? So the number of rows becomes 6 and column is still 5. So now suppose we keep the outer loop as 4 and change the inner loop to 6. What will happen is the number of rows become 4 and the column becomes 6. Each row contains 6 stars. This experiment teaches us an important lesson. Outer loop controls the rows and inner loop controls set columns or stars. Whenever you are confused, remember this single rule. So many beginners forget to write print after every inner loop. If you remove it, the output becomes one long line of stars. Let's try it, okay? So if we remove this one and if we run it, see all the stars are printed in the single line. So this is what is a mistake. So the another mistake is placing print inside the inner loop. So when every star is printed on separate line, this is not a required pattern. So always check the indentation carefully. So now it's your turn. Look, without looking the solution, if I want to print an output, like let me have an output 1 space 2 3 4 5 6, then 1 2 3 4 5 6, then 1 2 3 4 5 6. If I want to have this kind of output, what I'll be doing? How many times the outer loop should run and how many times the inner loop should run? Pause the video and think. The answer is the outer loop should run 3 times and the inner loop should run 6 times. That's it. So you don't need to memorize new programs. Just change the input limits according to the required pattern. So this is the first star pattern we learned. Observe pattern before coding. Count number of rows. Count number of stars in each row. Outer loop controls the rows. Inner loop controls the stars. Print end space keeps printing on the same line. Print function moves to the next line and then this is a simple star pattern. This teaches one of the most important ideas in pattern programming. In the next pattern, something interesting happens. The number of stars will keep change in every row instead of remaining constant. Now, let's slightly modify the previous pattern. The output is this one. So, notice the difference. Previously, each row had 5 stars, but now the rows of number of stars increasing by 1 in every row. That means our outer loop still controls the rows, but this time the inner loop depends on current row number. For So what we'll be doing is for row in range 1 comma 5 for call in range row print star comma end equal to space, and then after that print. So the idea is very simple. The inner loop is no longer fixed and it changes according to the current loop. And the third pattern is inverted triangle. So this one. So let's reverse it. The output will be this one. Instead of increasing, the stars decrease every row. One small change is needed here. Like let me open this. So instead of having row in range, we'll be having 4 to 0 and step value will be -1. So see how we didn't learn completely new program. We simply changed the loop range. So let's see right aligned triangle. The pattern is this one. Let We have seen this one, right? So what if we want to print right aligned triangle? The right aligned triangle will be 1, 1, 2, 1, 2, then 1, 2, 3. This is a right aligned triangle. So suppose I want to print this triangle to appear on the right side. Here we need two things. First, to print required spaces and then print the stars. So we use two inner loops. One prints spaces, the other prints stars. This shows that in nested loop can even contain inner loops. Don't worry if it looks slightly difficult. Let's practice and become very easy. So again, let's look at this pyramid. In this pyramid, the logic is exactly the same. First print number of spaces, then print stars. The only difference is that number of stars increases by 2 every row instead of 1. So every pattern is built using the same idea. Current row, count rows, decide spaces, decide stars, write the loops. The loop changes slightly. So let's quickly revise what we saw today in star patterns. Although we saw several star patterns, although their shapes are different, the approach never changes. Observe the pattern, count the number of rows, decide what changes, use the outer loops for rows, and use the inner loop for spaces and stars. Once you understand this process, you don't need to memorize every pattern separately. Now that we have learned how to star print patterns, let's move to the another interesting category called number patterns, where instead of stars, we'll print numbers using the same nested loop concept. Now that we have learned star patterns, let's move to the number patterns. The good news is nothing new needs to be learned. We are still using the outer loops, inner loops, and same thinking process. The only difference is instead of printing star, we will print numbers. So increasing numbers. Okay, so the output is 1, then 1, 2, then 1, 2, 3, then 1, 2, 3, 4. Observe first. The rows are 5 and the numbers inside increases in every row. So the code will be for row in range 1 comma 5 for call in range 1 comma rows plus 1 print call comma n equal to space then print new space. And if I save it and run, notice we are printing column instead of stars. That's the only difference. Okay, so let's move to the next one, pattern number 2, which is same number in each row. Let me go to the pattern. Yeah, this pattern. So first, which number should be printed? The answer is the current row number. So the code will be for row in range 1 comma 5, for call in range row print row comma n equal to space, and then print a new line. If I save it and run, so instead of printing instead of printing columns, we print rows. So pattern number 3 is continuous numbers. So the continuous numbers will be 1, then 2, 3, then 4, 5, 6, then 7, 8, 9, and then 10. Here the numbers did not restart. So we need one extra variable called num equal to 1 for row in range 1 comma 5, for call in range rows we print num comma n equal to space bar, and then we'll be adding numbers are equal to 1 every time we are having inside the inner loop. So if next time every time we print we increase the num by 1. This is a common interview question, by the way. So this makes 1 2 3 4 5 6 7 8 9 10. This and so now the next thing is reverse triangle. So this thing will look simple. 4 3 4, then 1 2 3, then 1 2, then at last 1. Logic rows decrease. So what will be for row in range 4 comma 0 comma minus 1, for call in range 1 comma row plus 1, print call comma n equal to space, and then print new line. See, only the outer loop changes, everything else remains the same, and we get the desired pattern. So in quick summary, let's summarize. In every number pattern, we ask the same question. How many rows? What changes? Which number should be printed? Should numbers restart or continue? Once you answer these the problem becomes easy, whether it's stars, numbers, or even alphabets. The thinking process remains exactly the same. Now we have completed the pattern programming. At this point, we will move on to the next important topic in Python called functions. Functions help us to organize our code, avoid repetition, and build large programs in a clean and professional way. Let's begin by understanding what. Now let's move to the one of the most important concepts in Python. In fact, it's not just Python. Almost every programming language has its concept. This concept is called function. So if you ever had used a calculator, a mobile phone, or even a remote control, then you might have been using the idea of functions without realizing it. Let's understand why. Imagine your teacher asks you to write your name 100 times. Would you type it manually every single time? Probably not. You would rather copy it once, paste it again and again. Why? because repeating same work is inefficient. So programming uses the same, use this the exact same. Suppose you have written a piece of code that calculates the average of marks. Now imagine the school has 500 students. Should you write the same code 500 times? Of course not. Instead, you will write one code once, give it a name, and use it whenever you need to it. This reusable block of code is called a function. So what exactly a function is? So a function is simply a named block of code. It's a named block of code that performs a specific task. Think of it like a small machine. You give a machine a job. Whenever you press the button, it performs the task. For an example, your washing machine has wash buttons. Your calculator has square root button. Your mobile phone has camera button. Every button performs one specific task. Similarly, every function performs one specific task. Advantages of functions. The PPT lists several advantages of using functions. Let's understand them very well. Okay, the first advantages is code reusability. Write once and use many times. Instead of copying the same code everywhere, we simply call the function. Second is better readability. Programs become easier to understand instead of reading hundreds of lines. We can simply read meaningful functions named like calculate total or display menu. The program becomes much cleaner. The third one is easy maintenance. Suppose you find a mistake without function, you may have to correct it and in many places. With functions, you change the code only once and every function call automatically uses the updated version. The fourth one is reduce repetition. One of the biggest goals of programming is do not repeat yourself. Functions help us avoid unnecessary repetition. So let's understand functions using a restaurant example. Imagine you go to a restaurant, you order masala dosa, and the waiter takes your order to the kitchen. The chef prepares the food. Finally, the waiter serves it to you. Notice something, you don't tell the chef every single cooking step. You simply request the dish. The kitchen knows very well knows what to do. Function works in the same way. Instead of writing entire code repeatedly, you simply call the function and the Python executes the instructions inside it. So now let's learn how to create one function. Give me a minute. Okay. So the syntax of function. Let's learn how to create one. The PPT shows the basic syntax, which is def, function name, and then statements. Let's understand every part. Def stands for define. It tells Python, I'm going to create a function. And next comes the function name. Just like variables, function also need meaningful names. After the name, we have parentheses. For now, they are empty. Later, we will learn why these parentheses become very important. Finally, a colon. This may marks the beginning of function body. Every statement inside the function must be properly intended. Indentation is compulsory in Python. So let's make our first function, which is def greet and print welcome to Python programming, and then end this, and that's it. You have created a function. Now here is a question, will this line automatically print the message? Many beginners think yes, but let's execute it. The output is nothing, absolutely nothing. Why? because we have only defined the functions. We haven't asked the Python to execute it yet. Think of it like writing a recipe in a notebook. Just because the recipe exists, the food doesn't get cooked automatically. Someone still has to cook it. Similarly, calling a function doesn't execute it. To execute a function, we need to call it. The PPT demonstrates how to call it using function name and parenthesis. And notice the last line, greet parenthesis. This is a function call. When the Python reaches this line, it immediately jumps to the function and then executes every statement inside it. Then returns to continue the rest of programs. Let's execute it. Welcome to Python programming. Now imagine calling 3 times. Greet, then greet. Okay. So the output will be welcome to Python programming, welcome to Python programming, welcome to Python programming. We didn't rewrite the print statement 3 times. No, we wrote it once. We reused it. This is the biggest advantages of function. So here is a common interview question. Remember the difference. Defining a function means creating it. Calling a function means executing it. Once we create a function, the other runs it. Never confuse the two ideas. Let's summarize what we have done in this topic. A function is a reusable block of code. Function reduce repetition. They make programs cleaner and easier to maintain. We can create functions using def keyword. Defining a function does not execute it. We execute it by calling the function using its name followed by parenthesis. In the next section, we will be making our function even more powerful by learning parameters and arguments and allow functions to work with different inputs and instead of always proceeding with the same output. So far, we have created our own functions. Such functions are called user-defined functions because we created them ourselves. But Python already provides hundreds of ready-made functions. These are called built-in functions. Think of like buying a new smartphone. Many apps are already installed like calculator, camera, clock, calendar. You don't create them, they already exist. Similarly, Python users already provides many useful functions like print, displays output, input, access input from the user, len returns number of characters, type tells the data type, max returns the large value, min returns the small value. These functions save us time because someone has already written the code. We simply use them. So here let's now see what parameters and arguments are. Now, till now, our functions always printed the same message. But what if we want to print different outputs? Suppose we want to greet different people. Instead of creating 10 different functions, we can use parameters. So, consider this example. Yep. So, in this, within parenthesis, let me remove this thing. I'm getting name and then print hello name. Here, this name is called parameter. So think of a parameter like an empty box. The box is waiting for a value. Let's call it greet Rahul. Greet Priya. Greet Bharat. So the output will be hello Rahul, hello Priya, hello Bharat. Let's understand the difference. Inside the function definition, def greet name is called a parameter. When we call the function, this part is called an argument. Remember the simple rule. Parameter receives the value, argument sends the value. Think about ordering food online. The restaurant menu has a blank space asking, enter the delivery address. That blank space is like a parameter. The address you actually type is the argument. Simple, right? Now, let's learn another important keyword. Sometimes, instead of printing our answer, we want a function to send a result back. For that, we use return. So, what exactly the return is? Let's do with an example. Def add a comma b and then return a plus b. Now, call the function like result equal to add 10 comma 20, then print result. And if I save it and run, the output becomes 30. Notice the difference. Here we use print a plus b. Like if we use the function would display the answer. The function comes, but using this thing return makes the answer come back to the program, and we can store it and reuse it or perform more calculations. This is why professional programmers use returns very frequently. The simple way of remembering it is print displays the result, return sends the result back. So let's quickly summarize functions. A function is a reusable block of code. Python has inbuilt functions like print, len, and many more things are there. We can also create our own functions. Parameters receive values, argument sends values, return sends the result back to the caller. These concepts form the foundation of functional programming in Python. Let's do one sample practice program which like create a function which checks whether you are an eligible voter. So this is a sample program. Here I'll be having a function called def check underscore vote. Check age. Here I'll be having age as a parameter, and within here age I'll be having if age greater than or equal to 18, return eligible, and else return not eligible. And after this, I'm having a variable called age where I'm getting input from the user. Input, enter the age. After that, I am having print check underscore age bracket age, comma, for vote. And if I save it and run it, as enter your age. And if I give 19, eligible for vote is printed. So this is exactly how functions work. Here we have inculcated concepts like functions, if else, input statements, and print statement, and also type conventions like int, etc. So I hope you have understood today's lecture. So let's revise everything we have learned in this today's lecture. Starting from understanding why pattern programming is important. Then we learned nested loops and understood the difference between outer loop and inner loop. After that, we have discussed a simple step-by-step strategy. 1 minute. Yeah. After that, we have discussed a separate step-by-step strategy to solve a pattern. Instead of memorizing programs, we learned how to analyze them logically. Then, we implemented several star patterns and number patterns using nested loops. Finally, we entered a completely new topic called functions, where we have learned what functions are and why they are useful, how to define them, how to call them, and then the difference between built-in functions and user-defined functions, where user-defined functions are already created functions which are there existing in the Python written by somebody else. We'll be just using them to have a ease of efficiency. And then we discussed about parameters and arguments. And then finally we saw about return statement, as return statement is quite helpful whenever we need to can use the function and get the output as a value and reuse it and do some calculations or computations with it in the future use. So today's lecture introduced two very important programming concepts, nested loops and functions. These concepts will be used throughout your programming journey. So, congratulations! You have successfully completed another milestone of Python programming. If you understood today's lecture, now you now have the foundation to solve basic Python programs and organize your programs using functions. As always, don't just watch the lecture, open your code editor, type every example yourself, charge the values, experiment, and observe the output. The programming is a very practical skill. The more you practice, the more confident you will become. In the next lecture, we will continue building on these concepts with more programming practice and applications. Until then, keep learning, keep coding, and most importantly, enjoy the process of coding. Thank you for watching, and I will see you in the next lecture.